In this video clip, we're going to learn about periodicity of the discrete time signals. Periodicity is the state where the signal is periodic. The signal is discrete time. Normally, the signal that is for the analog case. Okay. For the analog case, you may remember that for the analog signal, if it is XAT, okay, equal to XAT plus or minus T, okay, maybe I use the word T naught, okay, then in this case the signal is called for all T, okay, then in this case we call periodic, okay, we call periodic. But for the digital signal or the discrete time signal, the digital usually means discrete time and discrete value. So for the discrete time signal, you have xn, okay, and it should be equal to xn plus minus n naught, okay, for all n, okay, and we call periodic. Okay. The first one is periodic with period. T naught. The second one we call it periodic with period n naught. That means every n naught sample, the signal gonna repeat itself. Okay. For example, if I have a signal like this, okay. Okay, let's say I have xn equal to minus 1 to the power of n. Okay, so you see here that if I plot the signal when n equal to 0, okay, when n equal to 0 is equal to minus 1, which is 1, and then when n equal to 1, n equal to 2, n equal to 3, n equal to 4. Okay, so in this case you see that the signal itself, okay, is periodic. Okay, so that means it's equal to just when n equal to 0, minus 1, then you're gonna have minus 1, 1, minus 1, 1, and so on. Okay, when n equal to 0, you have that. So the period, okay, in this case is equal to 2, because the signal will repeat itself every 2 sample. Okay, every 2 sample. Okay, let me delete a little bit. N naught, okay, n naught equal to 2 samples. Okay, so this is the period. Now, what if the signal? Now, if xn is a sinusoid, okay, is a sinusoid. Normally, for a sinusoid, you think that it will be periodic, right? Because all sinusoids are periodic in analog domain. But in this case, it's not true. Okay. For example, if I have a cosine omega naught times n plus phi, okay, then xn will be periodic. Is periodic if, okay, only if, okay, when, because here omega naught is equal to 2 pi multiplied by f, okay, and here if you can write it as 2 pi n divided by r, 2 pi r divided by n, okay, and here is some ratio, okay, because here you're gonna have the period, okay, the period, okay, n equal to 2 pi r divided by omega naught, okay, so that has to be some kind of integer, okay. If it is not integer, okay, so if your n is not integer, then in this case you will see right away that you're gonna have a non-periodic signal, because the period for the discrete time signal, it cannot be non-integer, okay, because the sample is append every integer interval. So what is the value of r? Okay, so the smallest possible value of r will create n naught. Okay, so if you have the minimum ratio n r over n, then r is just some integer as well. So in short, okay, integer. In short, omega naught, if omega naught equal to 2 pi and then r over n, okay, then xn is periodic. And plus phi is periodic. So we learn more about this later on, and then how to find the period of the discrete time signal.